How many of the knives that came to you out of a dead man's toolbox did you make worth less in the first 20 minutes you owned them? That is not a rhetorical question. I get letters about it every month. A man's father dies, or an uncle, or a neighbor with no family, and somewhere in a garage there is a steel box with a padlock on it that nobody has opened since the Carter administration. The lid comes up. There are knives in there, real ones. And within the hour, somebody has a wire wheel spinning at 3,000 RPM and a can of degreaser and the best intentions in the world. My name is Walt Rennick. I am 71 years old. I spent 34 years as a tool and die maker outside Dayton, Ohio, and since I hung that up, I have had somewhere around 9,000 blades across my bench, most of them belonging to somebody else. Today, I am going to give you 8 things in the order you actually do them, from the second the lid comes off a sealed box to the night you put those blades away for the next 40 years. Total cost of everything I name is under $35, and you already own about half of it. Here is the part that will not sit right with you at first. Those 40 years in the dark did less damage to those knives than one Saturday afternoon in your garage will. The rust is not the emergency. You are. You have seen the videos. Everyone has. A brown lump goes into a jar, a mirror comes out, and nobody says a word for 14 minutes. Hundreds of millions of views on silence. What that silence never mentions is what got destroyed on the way to the shine. The maker's stamp sanded off the tang, the temper cooked out of the edge on a bench grinder, a factory satin finish buffed into a chrome bumper, original bone handles thrown in the trash and replaced with poured resin in 3 colors. I am not attacking a person, and I am not naming a channel. I am attacking a method, and the method has quietly ruined more inherited steel in the last 15 years than moisture ever did. I say that as a man who did it. For my first 11 years, I went at everything with 80 grit paper, a corded drill with a wire cup brush, a jar of vinegar left overnight because I fell asleep, and whatever motor oil was open on the shelf. I had a bench grinder and I thought it was a restoration tool. I turned a pre-war butcher knife blue at the tip once and did not understand for another decade what that blue meant or what I had thrown away. An old appraiser at a show in Louisville told me something in about 1984 that I have repeated ever since. He was looking at a knife I had cleaned up and he was being polite about it. He said, "You can always take more steel off tomorrow. You can never put it back." So before we start, if you have a box, a drawer, a tackle box, a foot locker that came to you, and you have been afraid to open it or afraid to touch what is inside, tell me what it is down in the comments. And tell me exactly what is stamped on the tang letter for letter. The tang is the part of the blade that runs back into the handle. I read those. And I will tell you now, the 8th thing on this list costs about $2. It is a sheet of paper, and it has saved more blades for me than every chemical and every abrasive on this list put together. Stay with me for it. The first thing is the one nobody does, and it costs nothing. When you find that box, you leave it shut for a day in the room where you are going to work on it. Here is why. A toolbox that has been sitting in an unheated garage or a barn all winter is cold, and the steel inside it is colder than the air. Carry it into a warm kitchen or a heated shop, and you have just built a condenser. Warm air holds a lot more water than cold air. When that warm room air touches steel that is 30 degrees colder than it is, the water comes out of the air and lands on the blade as a film you can wipe off with your finger. That film is not water for long on bare carbon steel. It is an electrolyte, and it starts new rust in hours. I have watched a knife that survived 4 decades sealed up grow fresh orange bloom in one afternoon because a man loved it enough enough to bring it indoors. So the box comes inside closed and it sits for 24 hours until the steel is the same temperature as the room. Then you open it. This is not my opinion. The National Park Service's Conserve O-Gram series on storing metal objects makes the same point in plainer language than I just did, and it has been the standard advice in museum work for decades. Control the environment around the object before you touch the object. While you wait, you do the inventory. Every blade gets photographed on a plain towel, both sides, before a single thing is cleaned. You write down what you see, where the rust is heavy, where the pitting is, whether the handle is cracked, which way the blade sits when it closes. 10 minutes with a phone and a notebook. You will want that record in a month when you cannot remember whether a scratch was yours. I skipped this step for 30 years. I skipped it because it is boring and there is a knife in your hand. The one time I needed it, I could not prove to a man that the chip in his father's blade was there when it came to me. That cost me $200, and it cost me the customer, and both of those were fair. Cold steel, warm room, 1 day of patience. Now you can look at what is stamped on the tang, which is the second thing, and the one that decides everything else. Every bit of the money in a knife lives in about 1/4 inch of steel near the handle. Maker's name, pattern number, sometimes a date code. That is the birth certificate. Sand it, buff it, wire wheel it, and the knife becomes anonymous, and an anonymous knife is a used knife. Let me put numbers on that because it is the difference between a nice story and a real loss. A case Wenty trapper in honest, unrestored condition, tang crisp, with the original bones still on it, is a $150 knife most weekends at a show. That same knife with the tang polished bright and the stamp softened is a $25 knife, and the man buying it is buying steel, not history. You did not remove rust. You removed $125. You need a magnifier, an $8 jeweler's loupe, 10 power, the kind that folds into a metal case about the size of a nickel. And you need raking light, which just means you set a desk lamp low and to the side so the light comes across the stamp instead of straight down at it. A worn stamp that is invisible under a ceiling light will jump out at you under a lamp held down at the level of the bench. What you are reading matters. Case used XXX under the word case on the tang from about 1940 into 1964. Starting in 1970, they put 10 dots under USA and took 1 dot away each year, so you can date a knife to a single year by counting dots. That tells you the steel. Before the mid-60s, you are usually looking at their chrome vanadium, which is a carbon steel and will rust and take a patina. After that, you are increasingly into true sharp, which is stainless. Those two get handled differently from this point forward, and if you cannot read the stamp, you cannot tell which one is in your hand. So, no abrasive of any kind goes anywhere near the tang, not one time. If there is rust sitting on the stamp, it comes off chemically or it stays. That is the rule, and I have never once regretted it. Let me stop here for a second. What I just walked you through, reading a tang, dating a maker, deciding what a knife is before you decide what to do with it, is about 1 page of Chapter 4. There are 11 more chapters. I put all of it into a book called The Restorer'S Bench, first edition. 158 pages, 12 chapters, organized by the decision you are facing rather than by chemical. It comes with the bench cards, which are the 1-page procedure sheets you prop against the vise with oily hands, a safety card, and an index arranged by symptom so you look up what the knife looks like instead of guessing what it needs. Link is in the description and there is a code on the screen. Tonight is the night you stop being afraid of that drawer. The third thing is the one that explains the box. Somewhere in a sealed toolbox full of rusted knives, there is very often a single knife that caused the rust on all the others. Pick up each folding knife and smell the handle. Right up at the covers, the panels on the sides of the handle. If you get something sharp and acrid, a little like vinegar, or something sweet and medicinal like an old first aid kit, you have found celluloid. Celluloid is nitrocellulose plasticized with camphor, and it is what knife companies used from the 1880s through about 1950 to imitate pearl, tortoise shell, and candy stripe. It looks wonderful. It is also chemically unstable, and it does not last forever. Here is the mechanism, and it is worth understanding. As celluloid breaks down, it releases nitrogen oxide gases. Those gases meet whatever moisture is in the air and form nitric acid right there inside a closed steel box with no ventilation. The acid attacks the blade the celluloid is attached to, and then it attacks every other blade in the box. That is why you will open a sealed toolbox and find one knife nearly eaten in half, with heavy pitting on the tools lying beside it, and everything at the far end of the box perfectly fine. It was not water. It was a chemistry set with the lid on. The fix costs nothing and takes 2 minutes. That knife comes out of the box and it never goes back. It gets stored by itself in a container that breathes well away from the collection. You do not seal it in a plastic bag. Sealing it is what killed the rest of the box in the first place. Once the degradation is running, you cannot stop it. You can only isolate it. I lost a whole cigar box of small blades this way in about 1991. 6 knives and one candy stripe jack in the middle of them that I thought was the prettiest thing in there. 2 years in a closed box on a shelf, and the 4 knives nearest it were pitted like the surface of the moon. I did not learn that lesson from a book. I learned it from the smell. Fourth, before any liquid touches any blade, you decide what steel you are holding, and I want to kill a myth while I do it. You have heard that a magnet tells you carbon from stainless. It does not. The stainless steels used in knives are martensitic, which means they were hardened by heat treatment, and they are magnetic. A 440C blade and a 1095 blade will both pick up a refrigerator magnet. The magnet test works for kitchen sinks, not for knives. What actually tells you is the stamp, the era, and the rust pattern itself. Carbon steels are 1095, 1084, W1, W2, 01, 52, 100, and the chrome vanadium the American factories used for decades. They go orange all over, and where they have been used and oiled, they go gray and then near black. Stainless is 440A, 440C, 428C, 154cm, ATS-34, VG-10, and the like. Stainless does not rust evenly. It pits in isolated dark craters, usually where something sat against it, and the metal between the pits stays bright. Why you care? Carbon steel wants a stable patina and a film of oil forever. Stainless does not want a pit and will not hold one, and the pitting on stainless is deeper than it looks because the corrosion drives down into the steel instead of spreading across it. Create a stainless kitchen knife like a carbon one, and you will ease a stain for an hour that was never going to come out. And a rule that covers both if the handle is bone, stag, antler, horn, or wood. None of it goes in a liquid ever, and none of it goes near heat. Those are organic materials with moisture in them. Soak them and they swell. Dry them and they shrink and split along the grain, and a cracked stag scale cannot be uncracked.
The Canadian Conservation Institute says the same thing in its notes on the care of bull and antler. Keep them away from water and away from heat. Handles get wiped, and then they get a little mineral oil and a rig, and that is all they get. Fifth is the step that does 80% of the work, and almost nobody has the patience for it because there is no trauma in it.
Mineral oil, the plain USP kind from the pharmacy aisle, about $4 for a bottle that will last you 5 years. The blade goes in a shallow pan with enough oil to cover it, and it sits for 3 days. The mechanism is simple. Red rust, which is hydrated iron oxide, is porous. It is not a shell on top of the steel, it is a sponge grown into it. Oil wicks into that pore structure by capillary action, gets underneath the loose oxide, and breaks the mechanical grip it has on the base metal. You are not dissolving anything, you are loosening it. After 3 days, rust that would have taken 180 grit to remove will come off under bronze wool with the pressure you would use to butter toast. Bronze wool, not steel wool, about $6 a pad. Steel wool sheds ferrous fibers, they embed in the pits, and in 2 weeks you have orange freckles you cannot explain. Bronze is softer than hardened blade steel, so it will not scratch the finish, and what it sheds does not rust. Work with the grain of the blade, meaning along its length from handle to tip, never in circles. Circles catch the light and read as damage forever, and you stay off the tang. 3 days of nothing, then 10 minutes of light work. I spent 11 years reaching for a grinder because I wanted to be done that same evening. I think about the blades I wrecked more than the ones I saved. I will be straight with you. 20 minutes of video is a sample. What I have written down is the whole thing. 12 chapters, each one organized around a decision instead of a product, printed in large type because I am 71 and I know what a bench looks like at 9 at night. Everything in it is done at a bench that costs under $40 to set up with no machinery of any kind. And every technique carries a line I call Check Me, with a published, dated source next to it, the National Park Service, the Canadian Conservation Institute, the ASM Handbook. So you are never taking my word alone. 60 days to send it back if it is not what you wanted. If you have been watching this thinking about a knife that outlived the man who carried it, that is who I wrote it for. You will find it wherever this video sends you. Description or code, whichever is easier. Some things ought to get handed down twice. Sixth, when oil and bronze wool have taken all they are going to take and there is still hard scale in the pits, you go chemical and you go with the cheapest bottle on the shelf. Citric acid, 90 cents worth, sold as a canning supply. 1 tablespoon to a cup of warm water, which is roughly the amount of water in a coffee mug. What it does is chelation. The acid molecule wraps around iron atoms in the oxide and pulls them into solution, and it strongly prefers oxidized iron to healthy metal. That preference is the whole reason it is safe and vinegar is not. Household vinegar is 5% acetic acid and it does not care. It eats the rust and then it keeps going into the good steel and leaves you a frosted, pitted surface. Everyone who has left a blade in vinegar overnight knows what I mean, and I am one of them. 15 minutes, 20 at the outside, then out. Scrub with a toothbrush under running water, and straight into a bath of baking soda and water to neutralize, a heaping tablespoon to a quart. That neutralizing step is not optional. Acid left in a pit keeps working after you have set the knife down. Then dry it immediately and completely, and I mean bone dry with a hair dryer if you have one, on low, held far enough back that the blade never gets hotter than a coffee cup. A blade coming out of acid is chemically clean, which means it is naked, and clean, bare carbon steel will flash rust in front of you in about 4 minutes. Oil goes on the moment it is dry. gloves and a window open. Citric acid is mild, but it is still an acid, and you do not want it drying on your hands. And nothing organic goes in the bath. Handles stay out of the water. On a fixed blade with a wood handle, you dip the blade only, holding it like a candle. Seventh, and this is for the one knife in the box that is actually worth something and is too far gone for the mug of acid. Electrolysis. The reason this method exists is that it does not remove metal. Every other thing on this list takes material away, a little or a lot. Electrolysis reverses the corrosion reaction electrically and reduces iron oxide back toward iron. The rust does not get scraped off, it gets unmade. For a knife with a rare stamp under the crust, that is the difference between a knife with a name and a knife without one. The setup is a plastic bucket, a tablespoon of washing soda, which is sodium carbonate, about $3 a box per gallon of water, a scrap of mild steel as the sacrificial anode, and a battery charger. The knife goes to the negative clamp, the scrap goes to the positive, low amperage, 2 amps or less, and you leave it a couple of hours. Now the warnings, and these are the ones that matter more than the technique. Your anode is mild steel. It is never stainless. A stainless anode releases hexavalent chromium into that water, which is a confirmed carcinogen, and you now have a bucket of poison you cannot legally pour down a drain. Second, this process produces hydrogen at the blade and oxygen at the anode. Do it outdoors or in a garage with the door up, never in a closed basement, and no flames anywhere near it. Third, unplug the charger before your hands go in the bucket. I did not touch electrolysis until I was in my 60s because I assumed it was for tractor parts. It is the most conservative method on this list, and it is the one I use on anything I am afraid of, which brings me to the 8th thing, the one I told you about at the start. It costs about $2, it is a sheet of paper, and it has saved more blades than everything else I have named. VCI paper, vapor corrosion inhibitor paper. It looks like brown butcher paper, and it is impregnated with compounds that slowly evaporate at room temperature and lay down a molecular film on any bare iron in the enclosed space with them. You do not coat the knife. You put the knife in the drawer or the box with the paper, and the vapor does it. It is what rifle manufacturers and machine shops have shipped bare steel in for 60 years, and a sheet the size of a magazine page runs $1 or $2 and works for about 2 years in a closed drawer. Here is why it belongs at the end. Everything else on this list is a one-time event. Storage is what happens for the next 4 decades, and storage is where these knives died in the first place. That toolbox you opened was not a safe place. It was a sealed container with no air movement, holding whatever humidity was in the room the day it was latched, plus whatever the celluloid gave off. That is not preservation, that is a terrarium. So, a light film of mineral oil on the blade, a sheet of VCI paper in the drawer, silica gel if you live somewhere humid, the little packets, dried out in a warm oven twice a year, and the leather sheath goes in a different drawer than the knife, always, because vegetable tanned leather holds acid and moisture against steel and will pit a blade right through in a decade. More good hunting knives have been ruined by their own sheaths than by use. Nothing on that list is a chemical you have to be brave about. It is a piece of paper and a habit. If there is a step I skipped or a mess you have gotten yourself into with something you inherited, put it below and be specific about the steel and the stamp. Next time I'm going to take apart the one repair everybody attempts and almost nobody gets right, which is a folding knife with a loose blade and a peened pivot pin, and why tapping that pin is usually the wrong answer. And I want to leave you where we started, the mirror polish video with no words in it, where the brown lump goes in the jar and the chrome comes out. That video is not showing you a restoration. It is showing you the last 20 minutes of an identity being erased, filmed from a flattering angle. Rust is a condition. Sanding is a decision. One of them is reversible and the other one never has been. Let the box come up to room temperature one day, no cost. Read the tang under a loupe and a raking lamp, $8. Find the celluloid by smell and get it out of there, no cost. Identify the steel by stamp and rust pattern, not by magnet, no cost. 3 days in mineral oil and 10 minutes with bronze wool, $10. 15 minutes in citric acid, neutralized in baking soda, under $2. Electrolysis with washing soda and a mild steel anode for the piece that matters, $3. And VCI paper in the drawer for the next 40 years, $2. Call it under $35 all in, and most of that you buy once. Against that, a single sanded tang on one good old pocket knife runs $125, and the family history that went with it does not have a price at all. They can keep the shine. I will take the stamp.